All right, let's try that again. So both molar mass and Avogadro's number are going to be used today. If you look, it has atoms, which was our hint that we have to use Avogadro's number. And then it has grams. So grams or mass is telling you it has to use a molar mass. So we're going to have 3 boxes, which means we're using 2 conversion factors. So I start with what I'm given, which is my 3.99 grams of potassium. Still not putting anything down there. And then I want to convert over here my last to atoms of potassium. That's what I want at the very end. So once I've done that, I just start following my units to see where each conversion factor goes. So this is grams of potassium, so I have to have the same unit down here. So anytime I see grams, that's where we're going to be using a molar mass. So this conversion factor in that box is going to be the molar mass of potassium. Since it's an element, I'll be able to get it just straight off the periodic table. So it's element number 19. So that would be 39.10. And that's always per 1 mole. In the conversion factors that we're using, whether it's Avogadro's number or whether it's molar mass, it's always going to be per 1 mole. Follow my units. I'm moles here, then I have to be moles down here. I see atoms, so that's my hint. I need to use Avogadro's number, so it's going to go with my atoms, 6.022 times 10 to the 23rd atoms per 1 mole. So at this point, I can just kind of double check myself. It does cancel out, so now I would want to multiply across. So 3.99 times Avogadro's number. Then after you got that answer, you would need to divide by, in this case, 39.10. And we have to worry about 3 sig figs, or we have to worry about sig figs, and that had 3 sig figs. So my answer would be 6.15 times 10 to the 22nd atoms. So if you had your calculator set differently, some people instead of 6.15 were getting 6.14. Did anybody get 6.14 on this? So at that point, I can't tell you exactly why it's given, and you still would have to have all this other part too. But anyway, I don't know why it's doing that, if it's the way that it's set up. And in that case, that would be something that I'd have to realize, and then take either answer on that. We didn't have that problem with anything else. All right, any questions on that one, where everything goes? All right, let's look at another one. My next one, same thing. How many grams of helium? So grams tell me I'm going to use a molar mass, and then atoms of helium, excuse me, that tells me I'm going to use Avogadro's number. So I'm going to have 2 conversions. Same thing, I'm going to start with what I'm given, 3.03 times, I can't read, got it written over that, 10 to the 21. And that is atoms. And I want to get over here grams of a helium. So here I use Avogadro's number at the end, but because I have my atoms first, I'm going to have to be using Avogadro's as my first conversion factor. So I follow my units. Atoms here, I have to be atoms down here. So that always tells me that's where Avogadro's number is going to go. So 6.022 times 10 to the 23rd atoms per 1 mole. And then I keep on with my units, moles of helium. I have to be moles of helium down here. I see that grams, so that's my hint that I got to use the molar mass. And helium is element number 2. So it has a molar mass of 4.00 grams per 1 mole. The 2 conversion factors that we are using in this unit, both of them are always going to be per 1 mole. So where the mole is, that's always going to be a 1. So now same thing, you're going to multiply across 10 to the negative 23 on the bottom, then you're going to need to put that into parentheses. So this would be the moment where I expect everybody to pick up their calculator and try to plug that in and make sure they get the right answer. Please, ma'am. No. How many sig figs is our answer going to have? 3 again. Right, what'd y'all get for that one? Nobody got anything? 0.020, but you're gonna need one more. So what's after that? No, I mean, you're gonna need one more number for the sig fig. 1. And my units are grams. Remember, this is one of those placeholders. So that's why I had to have these 3. Those 3. All right, why don't y'all give number 3 a try? See if you can get it set up. Same thing. You're going to be using atoms. So you're going to have to be using Avogadro's number and then also mass because you have grams. Craig Jones. You said it doesn't have a name on it. Ashland's. What for Ashland? On this one, you don't have to because it's at the top. Actually, I think it may be yours. Did you put like, I think it's yours. Gotta put units on it. All right. All right, what did we get for that one? How many sig figs did we need? 3 again. 6.55 times 10 to the 22nd. Atoms. Does anybody want me to work through that one? Yes. All right. All right. So I'm gonna get started. Like I said, I can tell I need both conversion factors. So I'm going to give myself 3 boxes, and then I'm going to start with what I'm given, which is my 0.755 grams of lithium. And then atoms is the unit I want left. So I'm going to come down here or over here and put it at the top closest to my equals, because it should be the only one that doesn't cancel out. So follow my units. Since I'm grams of lithium, I have to be grams of lithium down here. And when I see grams in one of my conversion factor places, that tells me I'm going to have to use the molar mass there. So lithium is a single element, so its molar mass would be 6.94 grams, and that's always per 1 mole. Then I continue moles of lithium. I have moles of lithium down here. See atoms, so that tells me that's where Avogadro's number needs to go. So 6.022 times 10 to the 23rd atoms per 1 mole. And then if you did a quick check with your units, you can see everything cancels out except for atoms, which is what I wanted, because that's what I'm trying to solve for. So at this point, you're going to multiply 0.755 times Avogadro's number. And I don't think you have to put it in parentheses if it's multiplication. And then come back and divide by 6.94. And I think, like we said, it's once again 3 sig figs. 6.55 times 10 to the 22nd atoms. And you could just put atoms. You don't have to put atoms of lithium. I do that sometimes, but just what the unit is fine. All right, any questions on that one? All right, so let's look at your practice. Oh, of course, obviously on the test, it's not going to say this is, you need 2 boxes or you need 3 boxes and you need to use both things as a conversion factor. So you're going to have to get that hint from the problem. So we'll just start off with, I'm going to look at number 2. It says, what is the mass of 0.38 moles of cobalt? So I have a couple of things, mass and I have moles. If I have mass or grams, and there's somewhere in my word problem, that tells you that you're going to have to use molar mass as one of the conversions. If I have moles, moles tells you nothing, because every problem is going to have moles somewhere along the way. And then if I have atoms, which is one of the types of particles, that tells you that's when you're using Avogadro's number. Remember, those particles could be atoms or molecules or formula units. Things that you're looking for as you read them. So like if I look at number 3, it says how many moles, once again, moles isn't going to really help me, of nickel is 3.88 times 10 to the 25 atoms. So all really the thing that helps me is atoms, and that tells me I'm going to use Avogadro's number. So only one, I'm only going to have one conversion factor. I move down a little bit. So we look at number 5. Find the number of moles of sodium in 145 grams. So we said grams or mass tells me I'm going to have to use a molar mass as my conversion factor. And then when they get longer, if you flip to the bottom, back or whatever, I think number 13, I think is the first one that does both. like we were doing today. So if you read number 13, how many atoms of palladium is 400 grams. So if you notice that has both things, that has atoms. So I'm going to have to use Avogadro's number. So that was one of my hints. And then it also has grams or mass, which tells me I'm going to have to use a molar mass. So that whenever I see I'm going to have to use both conversion factors, and that means I'm going to have to use the 3 boxes. So that's kind of how you have to attack it. All righty, so get out your practice and work on some of them. You can either work on the first ones or the harder ones in the back. And I'll come around and see if anybody has any questions. But you got to get started somewhere. Even if you start and you put down the wrong thing, that doesn't matter. That doesn't matter. You just need to figure out some way to get started to begin with.